Hi viewers, welcome to Sevi Vali Kelvi channel. So let us see the PN junction diode explanation by using PSpice simulation tool. So for that we go for search and we select this PSpice design manager. So this PSpice software will open. Now go for tool and select the schematics here. So now the new window will appear. So this is the window which is used for pick and drop all the various electronic components, and we are making circuit here. So for this we have to take a different number of components. So for designing a PN junction diode in forward bias condition, so first I just take power source, that is VDC, that is DC power source. For this I just give VDC here. I just take and place these components and give escape. So this icon is used for picking various parts or components from this PSpice library. So we just press this icon, and what are the different components we need, we can select from this library. And now I go for taking resistor. So for this I just give resistor R. So I just enter this R. Automatically we can drag and place your resistor here, and again we need to take a diode. So I can give small d. So now I just take a diode here and press escape, and now select this diode and press Ctrl R. We can rotate this diode. So now I am going to connect this diode in forward bias condition. So for this purpose, in top terminal is a anode and bottom terminal is a cathode. So according to this, I arranged this diode like this. And one more component, that is ground terminal we need. So that is ground, which is earth. So that ground earth component can be selected from this part and place it here. Now all the components are collected from the library. Now we have to make a connection between each and every components. So now we go for this wire tool and select this icon. Now the line is appearing. We can draw this line here. We have to carefully draw the line. In case any one of the dot is included extra in the circuit, at the time the netlist error will be created for the diagram. So at the time the circuit will not be run properly. So now the resistor and DC source is connected together. Again we are going to make a connection between diode and resistor, and the connection is over. Again we can take connection between diode and power supply. Now we can move this. Once again I draw the line which is connected with this ground. Now the connection is made properly. Now I press escape and I can zoom it. Now you can see the size of the resistor, diode, power supply, etc. Now this is the DC power supply and source. I can give the voltage value. So if I give 2 volts, I can double click this voltage value and I can set the attribute, that is the value of the DC source. I can give 2 volt here. And if you want to change the resistance value, in default value 1 kilo ohm is there. Now I want to change 560 ohm. I just click 560 ohm. I type it. And now the diode is connected in forward bias condition. So after that I have to choose this setup analysis. So in this place I have to select or enable DC sweep. So this DC sweep consists of different variables. So here the DC sweep variable type is mentioned as voltage source and the type is linear. Here I have to give voltage name, that is V1. That means what is our DC source, the voltage is named as V1. So for that here I give the name as V1 and the start value is 0 volt. So I can give 0 volt and the end value is maximum of 2 volt is given in this DC source. So for this I can give 2 volt here and the in between range are different values variation or deviation between one value to another values are differentiated by zero point 0.2 voltage. So that is incremented value. I can give this value and close this window. Now the values given for this circuit is over. Now we have to go for schematic. So before going to run this program, we have to save this program, otherwise it will not run properly. So now I can give name PN junction dot sch because of schematic. I just save it. So already this name is here. So I can give PN junction 1. Can save our file. So netlist not created. So this means some errors appear here. So in case any lines are not connected properly, the netlist error will be occurred. So at the time we have to solve this problem. We can't able to clear immediately. So we just close all those things and newly we have to open a new file and create a new project and then we go to draw the circuit and we have to clear this. So let us see. I just open a existing file. I have already created PN junction. So this is the various programs I have already worked out. So now you can see this. So after completing this circuit connection, we have to go for analysis, and in this analysis display results on schematic option is there. We have to display this because when you draw this diagram first time, so at the time this voltage value and current values are not enabled. So for this purpose we need to find what is the exact voltage drop across this resistor or what is the current flowing through this resistor. That value you want to find. For this we go for analysis and display results on schematic, and we have to select or enable this values. So for voltage value, we have to select enable voltage display, and for current, we have to select enable current display. So from this, we can understood the two voltages across this resistor, and the current for this resistor is 3.57 milliamps. This can be determined with the help of this value. So apart from this, if you want to run this program, so you have to go for this setup analysis, and here we choose this DC sweep, and here V1 and start value 0 volt, end value 2 volt, increment value or deviation between different periods are 0.2 volts, and click OK and close it. So now we can choose simulate. Now the program is running. That means the circuit is now running. Now in this window, we can see the graph for this PN junction diode in forward bias. So now we can select this. x-axis value. So we just double click it, and here x-axis value is there. VD1 can be selected here and press OK. And after that we can go for trace, add trace and ID1, and again press OK. And again we go for trace axis. Let us see this circuit diagram for PN junction diode in forward bias condition once again, because before drawing this diagram we faced some netlist error. So to overcome that problem, again redraw the circuit, and we have to place all the components from this parts library and pick it and place here, and we made a connection between all the different components. Now we have to go for this analysis and display result on schematic. Here we just enable this voltage display and current display. For this we can press this, and again go for display results on schematic and enable this current display. So now the voltage value and the current value for the each and every components which is present in the circuit can be appear here or display in this area. So what is the exact current flow through this entire circuit? So 1.410 milliamps for this closed path. So this closed circuit consists of one voltage DC source and one resistor, one diode. So the entire closed circuit has the same current. So 1.410 milliamps is the voltage current for this particular closed circuit. And what is the voltage drop across this resistor? 1 kilo ohm is 1 kilo ohm is 2 volt. So that means the total voltage is 2 volt, and voltage drop across this 1 kilo ohm is 590.50 milliamps millivolts. So these are the values can be displayed by using this analysis and display results on voltage value and current value. Now we can go for setting this value, that is setup analysis, and select this DC sweep and press this DC sweep again. And here the default voltage source is selected and type is linear is selected. Apart from this, we have to choose this name for this sweep is V1, because here the voltage 1 is the one of the source which is chosen here. So for this the same name V1 is chosen here, and the start value of this voltage value is 0 volt and the end value is 2 volt. That means here in this DC power supply or DC source we have set as a 2 volt. So that is the maximum value or end value for this DC sweep, and increment value is it is divided by 10, so 0.2 volts. Now we can press OK and close this window. Now you go for simulation. So click this simulation icon. The simulation process is now taken place. So once the error is not occurred, immediately the simulation process going on and the simulation window is appear here. This new window shows the characteristics of PN junction diode, that is the relationship between voltage and current, both in x-axis and y-axis. In x-axis we have represent this voltage, and y-axis represent the current value. So here in this graph we just double click it and select this axis variable, and D V1 D2 and press OK here. V1 D2 press here, and now the values for this x-axis are varied. Similarly for y-axis ranges, select a trace and add a trace, and here ID2 can be chosen, and after choosing this ID2, automatically the voltage DC voltage 2 volt set in this PN junction diode circuit. According to this, the relationship between voltage and current characteristics can be observed in this graphical window. So, in case if you want to increase the voltage value in this circuit diagram, instead of 2 voltage, if you give 5 volt or 10 volt, according to this, VA characteristics can be changed. In case if I want to change the values, here I can choose 1 kilo ohm now. In case 560 ohm or some other resistor values are taken here, according to this, the voltage drop across this resistor value will be varied. So similarly, we can find the voltage current characteristics for PN junction diode in reverse bias. So for this, we just arrange this diode in reverse bias by rearrange this anode and cathode, and again the same procedure is followed for this circuit. Finally, we get a reverse bias condition VA characteristics. I hope everyone understood this concept clearly. This is the graphical representation for VA characteristics of PN junction diode by using PSpice simulation tool. So the in descriptive manner in laboratories we have used the same components, and we found the characteristics of VA between by using this PN junction diode. The same can be determined with the help of the simulation tool for verification process. I hope everyone understood. Kindly subscribe my channel. Thank you all.